depending on your math background, you probably spent more time with parabolas than any other graph. So I'm going to cover the basics of parabolas here, and then we're going to jump into a full screen ACT problem. Remember, whenever I have a diagram in the problem, I like to work it like you would work it. Of course, the book comes with a printable geometry section for you guys to work them so you don't have to sketch every graph. Now, a parabola is the graph of a quadratic. Now, the third video in this set, we talked about functions in the first video, and they're zeros. In this video, we're going to talk about parabolas. The third video, we're going to talk about shifts and translations, which is a really important parabola topic. If I have this parabola, y equals x squared, that's pretty crooked. I had to look back and see how crooked it was. That's a little bit better, maybe. Why not? We have this parabola. It's going to look kind of like this, right? It's going to have a vertex of 0, 0. Again, don't worry too much about that right now. And the line of symmetry is going to be the y-axis. Why? Because it starts at 0, 0. So this is also really helpful if you're going to take the SAT as well. What's important is that for every given height, right, for any given height, the distance between the line of symmetry and the parabola is equal on both sides. I could fold this parabola in half like this, and it would match up perfectly. Match up perfectly. That's what a line of symmetry is. Now, of course, I can have up, down, side, and side opening parabolas. Side opening parabolas are x equals, and they're not functions, and we don't typically see them on the ACT. Down opening parabolas have a negative coefficient in front of the x, which again we'll talk about a little bit when we do the function shift and translations video. So there's 1, 0 to this parabola, meaning that the vertex, which we call the very most bottom or the very most top point of a parabola, is actually sitting on that x-axis. I can also have parabolas with no zeros or with 2 zeros. On the ACT, that's kind of what you need to know. On the SAT, they tend to like to ask you system of equations questions involving a parabola and a line. Those get kind of sophisticated. If you want, I'll do a question of the week video on those. All right. That's kind of all I want you to know. I mean, that's the basics. I feel like you've probably seen this a ton. If you haven't, I really get into detail about it in the book. Because we have a square, 1 squared is 1, negative 1 squared is 1. That's why it marches up the same way forever and ever, or marches down the same way forever and ever. And it's going to be symmetrical about that line of symmetry. Of course, that doesn't have to be the y-axis. It could be over here, right? Or anywhere else. That's the gist of it. Now, let's jump into our full screen problem and take a look at that. This is a pretty standard parabola question. We're given a graph with the zeros marked, and we're asked to find the equation. Very occasionally, you'll see it the other way around where they give you the equation. They ask you to find the graph, but they don't usually do that because then they have to draw a bunch of graphs, and that's kind of a pain, and it takes up a lot of space. So we have 2 zeros at negative 1, 0, and 2, 0. Now, remember from our factoring stuff, factor times factor equals 0, right? So we say the solutions of those factors, because if this times this is equal to 0, one of these things is 0. We find the solutions by setting the factors equal to 0 and solving. So we can work backwards using our solutions to find our factors. In this in this solution, x is equal to negative 1. That means our factor, got to get it back equal to 0, will be x plus 1. Same thing on the other side. If our factor is 2, it'll be x equals 2. And our solution is our solution is x equals 2. Our factor is x minus 2 is equal to 0. Sorry for jumping around on the screen. I'm not the best at this stuff yet. All right. So now how do we find our equation? We FOIL. First times x times x is x squared. Outer, x times negative is 2, is negative 2x. Enter plus x last minus 2. Combine our middle terms. X squared minus x minus 2. You could also kind of do this by marking off as you go. If you have trouble on the working backwards or the foiling, make sure you check out those videos on that and the material, because it's such a critical skill. I can't overemphasize that. You could also kind of mark off on this as you go. First thing you do is you say, well, look, one of my signs are going to be opposite, so D is out. This doesn't seem to make sense to me. A couple of other things. This would be symmetric, but you got to be pretty good at parabolas to do that. And if you're good enough at parabolas to do that, then you shouldn't have any trouble doing it the other way. If you plan on solving these by plugging all these parabolas into your stat plot on your graphing calculator, please learn how to do this. You just don't have time. It's very easy to make a mistake doing it that way. So that's it on parabolas. Now, the most important topic, in my opinion, is the last video in this set. We covered functions and their zeros. Now we talked about parabolas and their zeros. And last, we're going to talk about shifts and translations. Directly tested, but also an incredibly useful time saver and accuracy improver. Check that out.